thank you all for coming to the ARC forum. Hopefully you've had a interesting and fun and informative time, and obviously thank you for sticking around for this session. And if you're flying back today, obviously safe travels, and if it's tomorrow, then or the next day, then enjoy and have a safe travel. So my name is Tim Shea. I'm an analyst here at ARC Research. Been there a little over 9 years, and historically it was focused on the upstream and midstream oil and gas segments, and did some work in aftermarket compressor and turbine monitoring and controls and sort of optimization in that area. And most recently over the last year and a half, looking at robots and drones. And so that's kind of what obviously the focus of our session is, drones empowering automation and inspections. So we'll just, so basically some housekeeping issues. Ideally put your phone on vibrate. Provide feedback on the session, obviously, if you can, on the form app. For updates, this is the last session, so we'll pretty much get lunch boxes after this outside, and then, obviously save your questions and things like that. I'll have some questions at the end through a Slido thing, which earlier I did them in the first slides, but it didn't work the way we thought, so that's a lesson learned. So we'll just get right into it. So what I'm going to be talking about is kind of based on some published and ongoing market intelligence, or studies, if you will, that we've been looking at these markets. We've had Rick Riss, a colleague of mine, has been doing a drone session at our forum for probably the last 3 or 4 years. So he's had some, that was kind of the focus of our efforts. And then we wanted to kind of get into the market a little bit deeper. So we've done studies on drones for the process industries, obviously with oil and gas. I'm working on finishing up one, hopefully at the end of this month, on drone inspection services. Industrial robotics is more the traditional fixed robot you'd see on a automotive plant or something like that. Collaborative robots are kind of like basically the same type of fixed robot, but they're designed to be collaborative in the sense they can work next to a human. They don't need machine safeguarding and fencing and things like that. And there's an interesting one because I had to put a little bit of a distinction in my study, because I was looking at robots that were like the quadrupedal robot from Boston Dynamics, or AnyMall, where there's several quadrupedal robots, but the robots, the collaborative robots now, what they're doing, they're getting pretty creative. They're fixed robots, but they're putting it on an autonomous mobile robot, and you'd see it around a warehouse, and so they've got the arms and it can move around. So that's pretty interesting. And then we had guys in our supply chain team do a mobile warehouse robot study, and then also done a study, as I just mentioned, on the robots for process industry. But the topic pretty much here, I'll talk a little bit about robots just to kind of, because I think it's an interesting topic, and there's kind of a sort of a synergy, as I'll get into a little bit, between those two technologies. But so the drone market, basically the leader is DJI. It's a company out of China. There's a couple of other companies like Parrot and Skydio, and there's a couple of interesting guys working on things called autonomous drone in a box solutions. And basically what that is they're very much a hardened, you'll see on the right-hand side, it's basically an enclosure that's designed to be, weatherproof and things like that. And they can basically open up. The drone can fly a pre-programmed mission on its own, collect the data, whether it's whatever kind of data, maybe visual data, so a camera, it might be a thermal sensor, it could be, a number of different sensors that they may be incorporating. And then it flies itself back into the enclosure, basically lands, and then it recharges. And some of them actually have little robot arms that come out and swap out the batteries, and so some just charge the batteries. Different companies have different approaches, but it's pretty fascinating because you can, at the end of the day, that's where I think the future is going to be. I mean, obviously the FAA and other countries have their own similar organizations that are going to be, impeding that progress. But I think as this technology continues to be proven out to these regulatory agencies, we're going to see increasingly these type of autonomous drones. We don't even, because if you're looking at a pilot, that may cost you $150 an hour. And if you need an inspector or two, so you could be talking $300 or $400 an hour, to run some of these. So eventually, with the FAA and other countries get that all figured out, I think this market is going to see a little bit greater adoption. But the number one reason for any of this stuff is really safety. You're trying to keep an employee from climbing up a flare stack that's 200 or 300 feet in the air, or then you're saving the cost of scaffolding and all the time and cost associated with that. So safety is really the number one driver for drones, particularly, and also robotics. COVID-19 kind of accelerated that because companies, were basically for a period of time were locked down. So they had to figure, okay, crap, what do we got to do here? So what can we do? Some of them had drone programs that they kind of maybe had to bring out of the dust, out of the mothballs and really start deploying those, or they had robotics or whatever they had. So it's really it's a safety first driver. But what we're finding out is that with these drones, particularly as they get more and more autonomous, there's a lot more benefits from just safety. And we'll get into that a little bit here. So these are basically just a couple of pictures. Like DJI, I mentioned, is kind of the 800-pound gorilla in a sense, and that's both commercially and consumer with photographers and all these other things. They're a pretty big player. And SenseFly was owned by Parrot. They now over part of Ag Eagle, but they have like sort of that fixed wing, and then there's a sort of a VTOL, which means you can vertically take off, but then it becomes sort of a plane sort of thing. So those are typically for longer distances. Most of these drones, the majority are rotor-based, the battery-based, which limits their performance, to plus or minus 30 minutes. And if you add some payload on there, some sensors and things like that, it gets even less. So that's obviously a gaining factor besides the regulatory issues that the FAA and others like it. So these are sort of just conceptually some of the there's different types. You can see some that are like, maybe they have a 6 or 8 foot wingspan, and there's a company that I think it's Raytheon owns them, it's In Situ. They're doing, for military and also pipelines, but they take off and, they're kind of like a little small plane, and they're for longer missions. And most of those are either, gas or powered or, and there's some that are tethered that can actually fly for long distances, so but they obviously have a limitation about how far can you go with a tethered drone. So there's a lot of, different types of form factors and obviously battery technology and regulatory. Those are the two big inhibitors from these things really starting to take off. I'm still I'm not sold yet on all this delivery stuff. I know there's Walmart and these other companies looking at it, but the more I thought about it, I think for high priced, prescription drugs and some other things, I think, because I said, someone just said, what if you got a guy, flying around with a couple of fancy smartphones and some criminal sees that and they knock it out of the sky. And of course, then they can theoretically pick up the phone. So there's a lot of issues that I think that need to be worked out. Obviously, if that takes off, then how are you going to manage all these things? You need there's various things they call unmanned traffic management systems, or UTMs, and there's a bunch of different companies. And of course, I talked to one of these drone guys, and he said, once the FAA gets, lets things get a little bit more open to allow these things, then you got to standardize behind which one of these guys are you going to use. So that's going to take a few years to get that figured out, and we'll see what happens. Applications, obviously, again, I talked about hard to reach areas, and particularly those that are designed for longer. Some of the guys that are like some other Chinese companies, and they're designed to, just do power lines or vegetation or thermal cameraing on the power lines and things like that. And in fact, there's one company in China that's serving like the largest utility. It's like the Chinese utility over there in China, if you took the name of it. But they're, those are, and I think a big area I think that really had good thing is methane. Obviously, methane detection, monitoring, and leak detection to help enable, leak detection and repair and things like that, mitigation. So I think with ESG and sustainability becoming increasingly a real, requirement, I think that you're going to see more people trying to look and see if they can get various types of drone form factors to make that work. Obviously, surveying and mapping is a big application right away. Stockpile measurements, which you'd see in mining or something like that, or pulp and paper. And the interesting thing is that we're seeing increasingly, and we're going to probably hear about that in one of the presentations, about how these drones, when they're so, they're being AI enabled with image processing and 3D scanning and LiDAR and things like that. So they're doing, they're creating and enabling digital twins, which obviously is a pretty hot topic in a lot of different industries. Surveillance and monitoring, like of a plant or right of ways. And I think that's where a lot of the drone and box guys, they've been like Percepto and guys like Aerobotics and some of these other guys, they've, a big application for them is surveillance and monitoring of ports and containers, or a physical refinery, the plant perimeter security and things. And where I see an increasing integration of drones is that a robot guy will say, we autonomous, and then the drone guys will chuck it because their autonomy levels, they're much more mature, let's put it that way. And so they're working together with a lot of these drone guys. I mean, the drone guys are working with the robotics guys to enhance the automation, because what I see is you envision a drone going around surveilling aerially, and then if it'll signal a robot to check out a certain area, hey, this part of the fence has been tampered with or whatever the case may be. So I think there's going to be, in fact, AeroVironment, which is a company that focuses more on the military market from planes and drones, does some industrial stuff, and they acquired a company called Telerob out of Europe. They had these sort of like the tracked industrial robotics, and they're So they're seeing that there's going to be an integration of that. So I think we're going to see that increasingly coming in the future, particularly as the regulations on the drone side open up, and the autonomous operations. So we're going to hear about some of that stuff in one of these presentations. But that's really where that's going to be a big area, because you got all these pilots out there, and they're and let's face it, it's human nature. One pilot may be better than another pilot. So you have inconsistent data quality, collection and issues and things like that. And then you cannot, a drone that's programmed, you can run the same mission every time. And so you're going to get consistency of the data collected. And I think it's going to help in the analysis and the reporting and things like that. So there's a lot of things going on in my mind that I think, it's funny because I was joking. I was sort of sarcastically joking about all this so-called smart VC money was putting money into these drone companies a few years ago. And I said, well, they're a little bit too early. A lot of these guys lost a lot of money in some of these companies because the market is just, slow to evolve. They haven't covered the oil and gas market for a number of years. I know that you can say you think it's going to happen here, but you always got to kind of put in the reality factor there. It kind of moves a little bit slower than everybody hopes and wishes. But so I think there's going to be there's applications I won't even talk about that are probably going to be found out as people, use these in their applications, and they realize benefit in one little area. Then they say, well, what else can I do? And I think we're going to see an increasing amount of that. So basically, what's the drivers of adoption? We talked about the safety. That's obviously that's the real main reason. We talked about you can really increase the cost and really improve the time of inspections, which obviously has a time and a cost factor. You can increase the number of inspections during a day, because these things could just they just run these things over and over again. You don't have to pay a pilot $150, $200 an hour. If you have a pilot plus you got an inspector, you're looking at probably at least double that. So you're having the automated data collection and analysis, and with some of this, you'll hear about some of the SLAM-based LiDAR. You can get some really high-resolution imaging, which is really fantastic. BVLOS waivers are being, I guess I say expanded, but when I looked at the numbers, I think there was like 4,500 BVLOS waivers applied for at some point in time, and I think the FAA approved like less than 3% of them, and most of them are like, some utility guy that says, I want to go do emergency response, and they tend to get it that way, or you have BP in the North Slope of Alaska or something like that. But it's very limited because, they don't want them flying over people. There was, they just started allowing, nighttime flight, but you got to meet certain requirements. So there's a lot of things going on with the FAA, 107. And I was just talking to somebody at Percepto at this drone show I was at back here in Orlando in end of April, and she runs all their regulatory thing. And I said, man, you must be pulling your hair out, because she's got to deal with all these countries. And some of them are more progressive than others. And my impression is that the FAA and Canada and these countries are not one of the progressive. They don't care about adoption. They care about, obviously safety and things like that. So they're working with these guys now. It's been 27 months or 28 months probably by now. And the FAA just released like a 400-page report. And from the FAA's perspective, that was like a monumental thing, that they actually are starting to make progress. So there's a lot of hope that maybe, we'll see, because that's really, in my mind, is the number one inhibitor. And then obviously battery life is probably number two. So basically, there's a lot of advantages. I talked about the drone in the box. I think that's, even DJI came up with its own drone in the box thing. Is really, you just need to work with an enclosure guy, work on some of the comms. And so it's not a really complicated thing to do, but it's really the autonomous operations, and then the high D, as we're going to hear about the 3D scanning and imaging to create the digital twins and all that advanced AI imaging and things. That's where the battle is going to be won, because I think that's where the real value is going to be added. Obviously, we talked about some of the inhibitors, battery life, the visual line of sight requirements for a lot of them. But then if you go BVLOS, you still may need a visual observer, or you may need a chase car or a plane or something like that. So they don't make it easy on you. And those are certainly things that have been sort of impeding a little bit of adoption. But I think that the outlook is bright, again, assuming regulations can continue to sort of hopefully evolve, ideally, hopefully a lot quicker than they are, but that's the way it is. There's already been, all these guys have already been using drones, like BP and Shell, and these guys are already using them in the refineries and things like that already for, again, for the safety reasons. They don't want their guys going up and down these smokestacks and things like that. So there's safety reasons, they're saving time, they're getting better quality data. So there are all those factors that have been driving this adoption. I guess in the interest of time, I'll just keep going. But you can see basically, I think that there could be, a pretty good ramp up over here in the next, it's kind of hard to forecast because I don't really know when the FAA is going to kind of get out of its own way and let things, so it's kind of like I kind of be somewhat conservative. But I think if certain things happen, that curve could go, it could, the acceleration of the curve could be certainly more dramatically in the positive direction. Applications, inspections obviously is a big thing, and there's all kinds of different inspections. Could be visual, it could be using a thermal camera, they could be using acoustic vibration. They could be doing predictive maintenance theoretically, of various types of equipment. Leak detection, I think, is going to be an area that's a big one. I think surveying, mapping, and obviously change or progress detection, monitoring of those things, of projects and things like that. So that's an area I think that people are starting to see. And then surveillance, as I talked about. Maintenance applications, well, that was talking more about robots, but we'll get into that later on. So there's a lot of potentially new applications that, that I haven't even thought about. And I'm saying that's the exciting part is you get an end user that starts to really have some success with these things, and then they can come up with things that, some people didn't even think about. So that's really encouraging. I'll just touch a little bit about robots because I think even though this is about drones, there's still a lot of synergy because they're really what they're trying to do is enable autonomous operations. And that's what a lot of our owner-operated clients are moving towards. I mean, they come to us and they say, we're working on our autonomous roadmap right now, and they want to know about drones and robots. And I think you should be aware there's different form factors. I mean, obviously the quadrupedal are kind of the wheeled and tracked ones on the right. There's one, the SMP Robotics has a wheeled, four-wheeled thing that they use to go around, and they do that a lot for surveillance of facilities and things, but they have some set up for leak detection. And, and there's also kinds of form factors like snakes. They go around and they can go inside tanks and things like, inside the pipes and things like that. So there's a lot of different form factors. I think I didn't put any bipedal up here because there's none that I'm really aware of that's commercialized. There's a company called Singularity.ai that's got a really a humanoid looking thing. But I think that they're still very much in the sort of a development stage, and they might focus more on the commercial market initially. But I think there's actually a company called Unitree, which has as Unitree and Ghost Robotics. Those are two other lower cost, which is going to be a critical factor here. Cost and interruptibility of these. So users don't want to be locked into. So I think Boston Dynamics and other companies like that were smart to open up their APIs because they're building an ecosystem of companies. They're working with IBM and a whole bunch of other companies on sensors and edge computing and how to get the data into the cloud. So there's a lot of that activity, which is really exciting. And then the guy at Boston Dynamics basically told us that we look at this as kind of a mobile inspection platform. We want everybody to do what they can with this thing because they know that that's going to really expand the adoption. I hope that Hyundai's backing and will be able to help them lower costs on the manufacturing side. And then this is a little bit about the robots. Again, it goes back to safety. But with a robot, you don't have the FAA to worry about, so you have a little bit more of a flexibility. But if you're going, they have to test these things on platforms, because the stairs sometimes, if you try to use a wheeled or a tracked device in some of these things, it just doesn't work. The tracks fall apart, they break. The quadrupedal guys, one of the issues they had on one of the platforms, it was very windy, so they needed to, had a certain kind of wind shielding capability. How does it, handle those things? But they're getting much more agile and mobile. I mean, they can fall over and then get themselves back up. It's pretty interesting. You can go to I saw one of these shows, and they just, they walk around, they come up to you, and they sense that you're there. They walk around you. It's really, I think that's going to be really an exciting area to see that. A lot of the same things. And battery life is obviously investments. These Boston Dynamics one, right now, if you get an enterprise model without any sensors, it's probably at least $150,000. So it's, and that's, I mean, they told me that initially they think nuclear power stations, because there's obviously radiation. You don't want people to get in there. So those substations where they're highly electrified, those are areas where there's a big safety issue. And that's an easy one because that's where they see the value. But I think hopefully by then they can get the cost down, because Unitree, I think that one in China is like $10,000. It's obviously a lot more base model, and but even the Ghost Robotics is like less than $50,000. And that's where the pricing needs to go, because if you want to get mass scale adoption, you've got to be. And I thought it was interesting, this company called X Robotics, they're actually working with Yokogawa. Yokogawa is kind of like their systems integrator. They're the robot guys, and they're working with a software company called Energy Robotics, and they do a lot of interesting things with the cloud and things like that. But X Robotics basically has a robot as a service. I call it a RAS. And their model is not just the safety, but they come out and said, look, our base model is 35,000 euro. They're a European company. And they worked it out based on the availability of the robot. It works out to be like 12 euro an hour. So they're really going at that. This is cost competitive. It's not just a safety issue. I thought that was pretty smart. I think that, and I think, again, it's the adoption, because these guys will take it in the field, and rightly so. They test it for a year or two before they got to prove it out. They want to make sure they can't take a chance that this thing is not going to work as it's supposed to. So that's, but I really think in my gut that especially with any robotics, just come out with an ATEX certified. I think it's zone 1. So that's really going to help with a lot of these, refineries and, obviously with explosive environments and things like that. And I think someone asked me the other night about, have you seen any of these drones that are ATEX certified? And I said, no, but I'm hoping somebody's working on them. I think they're a little bit more complex to do than a robot, but I think that hopefully that'll be something, because I think that's another issue that people worry about is obviously, in hazardous environments. Obviously, like anything else we've talked about, the need for ecosystem partners is tremendous, especially if you're a drone manufacturer. Most of these guys don't make their own sensors or cameras, so they're partnering up with people left and right. And then a lot of these guys don't have the software capability. So there's companies that'll be developing the software platforms, not just for the autonomy, but also like Percepto's got its autonomous inspection and monitoring. They call it AIM platform, and there's a Precision Hawk and some of these other guys have these software platforms that are really geared for. Some of them focus on just utilities, some of them focus on oil and gas. So they're really trying to build these platforms because they realize that the drone is really the hardware. It's what you can add to it, the software, the sensors. That's where the real value, the juice is going to be. But I think that you'll see a lot of partnerships. We're going to hear about, drone service providers are playing a huge role because we have a lot of large owner operators, and some of them have to, in certain countries, they're forced to work. Like in the Middle East, if you want to work in, UAE, I talked to the guy at Falcon Eye Drones, Feds. They basically have a corner in that market because no one else can fly drones there. So he told me, he sort of explained to me about the economics of the American market. There's a lot of drone service providers here. It's a little more cost competitive. Like he can charge what he charges in the Middle East. He got no competition. So it's obviously, it's certainly, but that company got bought by Aerodyne. Aerodyne's the big service provider in drones. And there's another couple of other guys like Terra Drone, and there's a few others, but but that's a very localized, regionalized market, and I'm interested to see if they can scale that up. Obviously they're buying companies in Australia because they realize if they want to get global, they have to, you got to have a global presence. So this is kind of a busy slide. I probably should have tried to pare it down, but it talks a lot about different applications and just the real need to have partnerships. So if you're in this market, or you're looking at it, or if you're an operator or an end user, reach out to these different folks, because you're going to need, particularly on the robotics side, you're going to probably need an integrator like a Yokogawa or someone like that's going to help, integrate all this together. So that's a key thing. Oh, here we go. If you want to take this little survey, someone's already filled it out, I guess, but are you currently testing or deploying drones? So we're just trying to get a sense of the audience. How many folks are here are, not just thinking about it, but are they actually testing or deploying these? And then there's a few others we'll ask about, but we'll take a couple of seconds here just to see if anybody wants to. I guess you scan the QR code, then a link comes up, and then you can say yes or no, and then there's 2 or 3 other questions that. So there we go. We're getting some. Wow, it's a higher number than I thought. Maybe. I don't know if it's just we get a small sample or that's. But it's interesting to see because I think there's been. A lot written about drones, and I really do think that there is value there, and I think that there's probably 10 or 12 companies that are working with the FAA to try to work with what they call a type certification. So a BVOS waiver is a very specific to a specific mission. That's it. You're only from here to there. You want to do something else, you got to get another waiver. So they're trying to work on something called a type certification, which will open it up across a model. So if DJI has a Maverick 600 or whatever model it is, if they can prove out that drone to the FAA, that drone can fly beyond visual line of sight across all missions. And unless they make material changes to the drone, I think my understanding is then that's when they have to recertify. But that's still under development, so it'll be interesting to see. But that's a pretty good number, right? I thought the fact that there's 40% here, people, that's better than I thought. So that's great. We have another question here. If yes, for which applications or operational areas are you testing or deploying drones? Obviously, I think a big one is probably inspections and surveying and monitoring. And when I say stockpile measurement, I'm talking about they fly over a mine and they can measure the surface, so they can get the measurements of the mine. It could be pulp and paper. Or I think leak detection will be one, particularly the ones that are designed for the longer duration flights that have more of a fixed wing one that can fly for several hours. And because it's if you're looking at a rotor drone, you're flying up and down missions. And if it's autonomous, it's not as much of a challenge. But if you're paying a pilot or an inspector, you're paying for their time. It's, you want to try to minimize that as much as possible. So not surprisingly, inspections is the big one. We'll give that a few more seconds here. So I've been talking a little longer than I hoped, but anyways, that just gives you an idea as to what some of the applications, and then if you're not using them, are you looking at them at all in the next 12 months, year or two? I kind of thought if you're not looking at it basically beyond 2 years, then it's almost like a no or never. But it would be interesting to see. That means you might be looking at them. I would not surprising. Don't know is a high answer. So I don't freak to those to the final results. Like, are they going to be baked in at some point, or is that, I don't know how that works in terms of. Okay, but if someone sees the presentation later on, they'll be able to see those results or not. I don't know how that works. Okay, all right. Well, I want to get the chance for these other speakers to. So I want to thank you very much, and I'll first call up Drew. Let's hear from Drew Talley here from Aerial Production Services. Thank you.
Appreciate you, I guess, leading off, Tim. That helps out quite a bit. It kind of gives us a baseline to go on for drone operations, and I appreciate the ARC Forum for allowing us to come and speak today. What I'm going to talk about, and first off, I'm Drew Talley. I'm the Field Operations Manager for Aerial Production Services, so I manage all the oil and gas operations for that company. We're going to talk about creating a digital twin of a complex asset, much like this compressor station that you see here, but we're going to go a little bit deeper than that. We're not going to talk about the software that's required to create digital twins and modeling, things like that. We're going to talk about the capture portion of it. How do you seamlessly capture these 3D point clouds, and how do you get it into a usable form that some of the software that, like the Bentleys and other software providers here at this conference, utilize this type of data. Before we get into that, let's talk a little bit about Aerial Production Services. Of course, we're a drone service provider, but we tend to not consider us as just a drone service provider. We go out and research the best sensors, the best drones, the best technologies, whether it's ground-based sensors or aerial-based sensors, and find a way to deploy it for our customers' problems. We look for, what answers are they trying to find, and what sensors can we provide a customized solution to help answer those questions. So we were established in 2014. We've flown 35,000 plus sites in 49 states. We're honestly still trying to get to Hawaii, but we can't justify the cost to fly a pilot out there right now. So maybe next year we'll get to it. We service 3 major verticals within Aerial Production Service. That's cell tower, construction, and oil and gas. And within the oil and gas, what I'm seeing is our customers are increasingly seeking to digitize their assets. They're looking to figure out how do we utilize these point clouds to gain insights into the conditions of their assets, the conditions of their site, monitor changes over time on whether it's a facility, they're adding new equipment to it, the as-builts that they had for it have changed. How do you keep up to date with all of those things? Or in North Dakota, we have snow melt every year. Well pads, they change. The erosion that happens on those, they need to stay up to date with it so that they can deploy their technicians to fix those problems in a timely manner and triage it to figure out where to send their assets first. It improves the decision making. You can make these decisions from an office instead of sending a guy out to the field to collect this data and then come back, make a decision on what you're going to do, then send the guys back out there. So you're reducing windshield time. But collecting this data, it's hard. It's not easy. It's to get good data for our customers to be able to use them in gain the proper insights from them instead of just throwing them a point cloud and saying, here you go, good luck. And our customers are like, well, what do we do with it? So there's challenges, but there's also opportunities to deploy customized or different types of sensors to collect this data. We'll talk a little bit about a gas compressor station that we captured about a year ago. It's not super complex, but it is complex. I mean, we've got some pipeline, we've got a co-located valve station, we've got cooling towers, separators, we've got compressor skids, we've got compressors inside of a building, and a lot of piping that's related to this compressor station that's outside. It can be difficult to be able to capture piping from a LiDAR perspective. Being able to capture it fully, it's quite difficult. So this customer came to us and asked us, scan the site for us, both indoors and outdoors. We want above, below, between. We want a full picture of our entire compressor station. We don't want any gaps in the data. And we don't want you to get in our way. We don't want you to shut down our plant. We don't want you to mess with our operators. We want you to get in and get out and give us this data. And we said, okay, we'll find a way. How do we do that? So terrestrial LiDAR. We've used that before. Everybody have seen ground-based LiDAR scans. They can be time-consuming. They can, you got to get closer to the equipment. If you want to get above stuff, you got to get a scissor lift and put one of your operators in a hazardous situation to capture some of that data. We can do it, but is it the best answer? Maybe. And we're a drone company, so we thought about, well, let's utilize a aerial-based LiDAR. Does that fit? Well, yeah, it can. We can get the roof. We can get all of the above ground assets, and outside we can see all of it, but we can't see underneath anything. So we were like, well, maybe it's a combination of terrestrial LiDAR scanning and an aerial LiDAR scanning, put them together. We've got to use one software to process the ground-based terrestrial LiDAR. We've got to use another software to process this other one. We've got to find a way to merge them together and make them fit right. So we were like, well, we've got another technology out there, SLAM-based LiDAR, which Tim mentioned earlier, simultaneous localization and mapping. We use this in our company for under-bridge pipeline inspections. We need to be able to get underneath a bridge where it's a GPS-denied environment and put our drone in a position to be able to inspect that pipe properly without, the risk of running into the bridge or crashing a $100,000 drone and, not being able to complete it for a customer. We've got to eliminate those risks so that we can do that. So we put a SLAM-based LiDAR on there, which can build the environment around it and then create a safe space or a shield around the drone so that operator error isn't of concern. You don't have to worry about, a pilot that's thinking about getting into a better position to get a better angle on the pipe to get that certain picture, and he goes up stick too much and tries to fly it into the bridge. The majority of problems or the crashes in the drone industry is pilot error. It's not hardware. So eliminating that pilot error is crucial to us. The speed of data capture. SLAM allows us to not, beforehand sit there and try to plan a route above a compressor site to be able to capture all of it and then look at the data and say, oh, I didn't capture something. Real time, we can fly this around, look at the data on a screen and make decisions. Our pilots can make quick decisions. Oh, I need to get this other angle. I'm missing a part. I'm having some shadows in my LiDAR data. So we're able to create a dense shadowless point cloud with the Emacent hover map system. So we went with that. We mounted it to a DJI M300 drone. We used the pilot assist mode. With the pilot assist mode, they have 3 different modes on this. You can fly it as a dummy payload. You can fly it as what we can call mode 1, where we are creating that shield around it. We're eliminating pilot error and the risk of running into anything. Or they've got a mode 2 where you can fly this completely autonomously. You can pick a point in space and say, fly there, but don't hit anything. And the drone with the Emacent LiDAR system on there will fly to that point, create a picture of what they're seeing, come back, show you what they're seeing, and then you can make decisions to continue like they use in Australia. They use it for stope inspections and mining. They're able to send it into hazardous situations autonomously, have it capture that data, bring it back to you, and show you what it's seeing so that you can make follow-on decisions. And of course, we can capture data with the hover map system in hours rather than days if we were doing a terrestrial scan. So getting back to the compressor station, we were able to capture this entire compressor station with just 2 25-minute flights and, of course, a 20-minute ground walking. We can take the hover map system off the drone and actually walk it around, or we can attach it to a vehicle and drive it around. It's a very versatile tool for us. So, of course, with this example, we don't have the interior of the compressor station. We couldn't get them to approve showing that off or anything, but what we're seeing here is what is approved. 2 25-minute flights and a 20-minute walk. That's, 70 minutes. Versus if we were to do this with a terrestrial scanner, I'm looking at least 150 different scan locations at 4 to 7 minutes per scan. And that's not including me having to continuously move this piece of equipment around. So we're talking about days of inspection versus a few flights. We also eliminated the need to have our personnel get real close to the equipment. We could fly the majority of this from 100, 200 foot off. We didn't have to get close to the equipment. We eliminated the need of our employees having to get into hazardous situations to capture this data. Limit the time. That risk mitigation is what drones are all about. I mean, getting people out of harm's way. So what we did is, in utilizing this system, is we reduce risk for our operations team. That's from my perspective, from the drone service provider and managing all these operations, that's key. Safety is number one for us. But we also we cut our inspection time by utilizing the right tool for the job by 80%. We reduced our post-scan processing time by more than 40%, and I could probably argue that it's a lot more than that, because while we're out in the field, we're continuing to capture more things past just the point cloud. So we're going to go capture valve information, valve manufacturer information. We're going to capture pictures of welding locations and taps and different information that we're going to supplement the point cloud with to create a full picture, a digital twin that our customers will need. So while we're capturing all of that, we're processing it on a standard laptop in our truck. By the time we're finished capturing all the information, all the pictures, the same day, we're able to look at that point cloud. Those 3 different scans, we've already processed them. We've already merged them. We're able to look at an unclean point cloud on site so that our pilot and our VO, they can look at it and say, okay, maybe I missed something over here. I might need to go do another flight real quick to capture that, so that from my perspective, I don't have to, bust my budget by sending them back out there for another day to do this, because what we're doing with drones is we're driving down cost. We're not taking 3 days to capture this, 3 days of man hours on my part that, of course, I've got to charge my customers. So we're driving down cost, and we're doing it because we can use one single versatile tool. And switch gears a little bit. I think I hit the... Switching gears just a little bit, the point clouds, they're all pretty. Everybody loves it. Everybody loves to see a little point cloud and, oh, this is cool, and, circle around inside of your little viewer. But what do you do with it? Do you make a CAD drawing of it, a simple little CAD drawing? Do you model it past this? Do you add, not sure if the video's, okay. There was a little video attached to it and about 4 more slides, but. Oh, well, I guess you don't have the rest of the slides, but we'll just ad lib. The other things that you can do with it is you can supplement these with like leak detection data. We do a lot of drone leak detection within aerial production service. So we'll go out and we'll capture say a well site, and we'll take all the information from that well site, whether it's the well names, the tanks, the separators. We'll digitize it, and then we take all the information that I was talking about earlier. Maybe it's the manufacturer of a Nardo valve or a thief hatch on top of a tank. We'll take that and pair it with that point cloud data in a GIS form, so that our customers are able to see the GPS locations of all of their assets, and then the inspections that go with it, the inspection data from either leak detection or a visual inspection or corrosion inspection. We had some slides of a flare stack inspection that was completely digitized that had a refractory casing crack on it. We can measure the refractory casing crack that has some buildup on the flare tips, had some corrosion on the line going up to it, and then on that same site had a major severe leak going on. So we were able to look at a whole well site holistically from a 20,000 foot view from the office. You didn't have to send personnel out there to look at that. You can look at it from the office and decide, okay, well, there's more going on here than what's at face value. Maybe the equipment's operating just fine. Maybe the separator is just venting off like it's supposed to, and we've seen some leaks. Or maybe it's dumping straight to the tanks, and we need to get an operator out there to do this certain thing to fix it, so that the separator's not dumping straight in. Maybe we got too much pressure on the lines. Who knows? They can make those decisions from the office and deploy the field personnel with the knowledge to do what they need to do without having to go out there, assess, come back to the office, pick up more tools, or look at some more drawings, and then go back out into the field and fix it. They need to be able to deploy with the knowledge in hand. And that's what this LiDAR data helps us do. You build that whole picture for our customers utilizing the right tools. Thank you.
Good morning. My name is Carrie Schuster. I work with Florida Power and Light, part of NextEra Energy. I'm a lead project manager, and we're integrating a lot of what we're hearing today in our work processes and flows. So we're going to get into a little bit about what we are doing with the data. This is a Taros drone that FP&L does have. We don't have it in the air just yet, but we plan to utilize that in the near future. So NextEra Energy is the world's #1 producer of renewable energy in the world, right? We were named one of the world's most ethical companies 14 times. We have a large footprint, not only in Florida, but across the United States and into Canada as well. I'm particularly with the Vegetation Management Department. Our Vegetation Management Department is responsible for the inspection and maintenance of utility lines in 47 states and in 4 provinces of Canada. We have tens of thousands of overhead distribution and transmission lines that our folks are out there inspecting and maintaining. Particularly in Florida, we are the largest utility in Florida. We serve about 5.7 million customers with about 800 substations. Just to touch a little bit about what Tim was mentioning earlier with the Perceptos drones, we deployed Perceptos at our substations now, right? So we're ramping up, but it's really good to have that Perceptos, the drone in the box, at different substations for a quick visual of what's going on, particularly after storms. And if we need to get some quick eyes in the sky, that's the way we're able to do that. So with line clearing, tree trimming, and utility line clearing, Florida's a little bit different. We live in a subtropical area. The trees grow year round. We don't normally have a dormant season for most of our vegetation. I am a certified arborist as well, so I've been with the vegetation department going on for about 17 years. And there hasn't been a lot of innovation, particularly in the line clearing space, right? Climbing trees, hand saws, ropes, we moved into the space of bucket trucks. We do have, we are testing equipment now with remote controlled operated trucks now in our system. But primarily the future for our department and our system is really AI modeling, predictive growth, drones, capturing imagery. And like what we were talking about earlier, what do we do with it? What do we do with the imagery we have? So ultimately, we've been on a journey over the last year, and even more than that, actually, the year and a half, to transform our business model with vegetation management. Our historical approach is really manual inspections, labor-intensive, paper-based maps, very subjective inspections, random quality checks, and we're paying by the average cost per mile. It was very difficult to understand what is the work we have out there? What is the scope we have in the areas we have? So we've been moving more towards an intelligent line clearing trim cycle. We have, with the use of GE's visual intelligence platform, we have been able to get into a space where we understand the work scope, automated work designs, and we're going to use that information for predictive growth modeling and change detection. We've been on a journey over the last couple of years to transform our business model. Using LiDAR is not the first step in the journey. We first were able to make a difference with our processes using aerial and satellite imagery. We'll talk a little bit more about that. That did change from our legacy systems into our current process and where we're moving into over the next few months. So again, from 1992 to about 2018, we're all paper. You can see down here on the left, that's a manual inspection that we have. It was not unusual for these papers. And remember when I said we have tens of thousands of overhead lines being inspected each year? This is the result in which that would come. A lot of highlights, a lot of tick marks, a lot of comments on there. And what do you do with that? It's very subjective. Then in about 2019, we moved to our electronic inventory. We moved to a paperless workflow system at that point with work management. We were able to use satellite and aerial imagery to understand where we think vegetation is, but we didn't have a lot of information about the vegetation that was in that area. It did move us in the right direction, and it prepared us for the next step in what we're taking in our journey now. So we have a GIS inventory. We were able to capture the satellite and aerial imagery, understand where we feel vegetation is, have inspectors go out there and validate the information, and essentially get it paperless onto our crews in the field to execute the work. But the future, which we're in now, which we're stepping into now, is optimized, lean, and smart. We have a lot of different imagery being collected in Florida Power and Light and NextEra. We have access to a lot of different data, not only for the use of vegetation management, for pole inspections, asset inspections, right? So we are now in a space where we are accessing that data and seeing how we can use it for vegetation management purposes. We have been using the GE digital platform, Visual Intelligence. We'll get into that a little bit more. So we then take the collected data and we process it through the Visual Intelligence platform, which creates a 3D twin of our electrical infrastructure, as well as designs the work that will be executed in the field. So we have an automated work design, if you will, that now we don't have to create from scratch. We validate and we can look by exceptions. From there, we will feed that work scope into our work management system. We have optimization of scheduling and execution, and we're going to use that data for our future predictive modeling. Inside the Visual Intelligence platform, we also have our electric network model. We have this GIS visualization of our assets in the field, right? Our overhead power lines, our transformers, our assets that we need in order to understand and overlay with the imagery collected. So we did a statewide sweep recently. In the fourth quarter of last year, we had a statewide sweep. We are among the first utilities going into the distribution space with LiDAR and using it down to distribution, down to the feeder and neighborhood lines, in the neighborhood lines that serve customers' homes. Typically, the space is usually for the larger transmission lines, right? So we are now going in. We just did a statewide sweep, all of our distribution and transmission lines in the fourth quarter of last year. We created the digital twin using visual intelligence. We were able, visual intelligence does automatically classify the information, so we are able to understand poles, wires, buildings, ground, and vegetation as well. So from there, we were able to understand encroachment, the vegetation encroachment on the overhead conductors, focusing mainly on feeder lines. So you can see on the right here, those colors that you see, we were able to configure and work with GE to determine where do we have areas where the vegetation is too close to the power line. So now we're able to know how much vegetation is there, where it's at, and how close it is to the line. Before we were able, with satellite and aerial imagery, we're really only able to understand, we think vegetation is in this area, but now we have a lot more information to make just smarter business decisions. We are taking the data that we're collecting, the output from the visual intelligence platform, and we are updating our GIS inventory as well. We did have some lessons learned, right, from the statewide sweep. As we heard earlier, collecting the data in the right way is imperative, right? So we had to go back a few times to make sure we had absolute accuracy instead of relative accuracy, because we want to use this data for growth modeling, predictive analysis, to understand not only what do we have out there now, but what is it that we need to trim, and where is this locate? What are the growth rates in certain areas, so we can get ahead of where we feel the work would be to help us with our business forecasting. Not only do we have the 3D viewer in visual intelligence, but we also have 2D polygons. In addition, the platform automatically creates our work zones. We have work zones there in red, and we configured them using in partnership with GE to understand how our crews execute their work. So these work zones are essentially unit-based designs. So we now know how many work zones, how many setups our crew will need to execute the work. The colors there are based on the distance from the line. You can see little boxes there with colors. Red would mean it's anywhere from 0 to 4 feet away from the overhead primary. And then subsequent colors are the feet out from there. We work through classifications again, right? We talk about collecting the data, then the specs in which you collect it. We've learned through this process is very, very important. Working through misclassifications, the way the data was collected as well, and working through noise, if you will. I mentioned that from the collect, we have this detailed work scope. So now we're able to determine not only where the work is, what the work is, but how much is there as well. And this is driving our transformation of our current contract constructs. We're using this information to renegotiate our current contracts and unit-based pricing instead of cost per mile, where there may be work or may not be work in that mile. This is an example of work execution. To the left-hand side, you can see you have some red areas. Let me see if I get this pointer right. Right here, you can see there's vegetation and the power lines, and you can see we have encroachment within 0 to 4 feet of the overhead primary. We're then able to use drones, and I'll talk a little bit about that, to do automated quality inspections. So not only are we using the baseline information for the statewide collect and all the other collects that we have access to, but once the vendor turns in the work as completed, we are deploying drones throughout the system to fly the job area again, putting it through visual intelligence and doing an automated quality assurance assessment. So visual intelligence will actually understand the collect dates. It's integrated as well. It's receiving information back from our work management system to understand when the work is completed, and the next flight, if it's within a certain number of days, it will consider it a quality check, and it will compare and let you know where we feel potential rework items are. So you can see there they were able to clear the vegetation that was close. So we will set the parameters in the platform, what's an acceptable level of footage, and determine then the platform will automatically spit out where we think rework is. Same down here. We had some imagery of before and after the work was executed. We have a lot of palm trees down here in South Florida. It's very hard to keep them out of the power lines because of how fast they grow. Their fronds will be back in the power lines within a few months. So we are able to, and this is an example of the before and after from a palm tree in the overhead power line. Obviously, we can leverage this data to monitor compliance, right? We're able to extract all the data from not only where we feel the volume of work is, but also the execution rate and the distance of conductors. So all of this is going to be used for the next step in our journey, which is true automation and predictive analysis so we can understand and forecast and changes with the rain, right? Overlaying different information and really using data science to propel the program to really provide value for our customers. So our next steps, we talked about this, which is tree segmentation. So right now, we understand from a polygon lines or grouping of trees, but we really want to get down to the actual tree segmented itself. And we want to know the growth of that specific tree versus a clump of trees or an area of trees. All of this would be used for storm response. We are leveraging the data to understand specifically with change detection before and after storms. And then having this platform that can take the data collected and process it to this level really helps us understand where the areas of work is needed and where to deploy resources. That's it.
Mark Susich from Emerson to introduce himself and let us know a little bit more about what you guys are doing.
Certainly. Good morning, everybody, and thanks for showing up to the last session on the last day. Really appreciate the audience. Mark Susich, I'm the oil and gas technical consultant with Emerson. 30 plus years in the oil and gas industry, primarily upstream, where I've had the pleasure to implement and manage asset integrity programs on a global basis. Critical to this theme, 10 plus years, defining and implementing remote autonomous inspection, and then working on machine learning for certain NDT methods. Pleasure to be here. Look forward to your questions.
So I guess as usual, I'll throw it out to the audience. We have a microphone, so raise your hand, and then if you could, just introduce yourself and where you're from, and then ask a question. Here we go. Should be on. Is it on? Yep.
Mike Richards, Johnson & Johnson. Question for Carrie and others. I didn't know whether or not you had said that some of your drone operations, if any at all, were autonomous. It seemed like it would be a good opportunity to have a pilotless open air. Are you doing that now, or if not, looking to adopt that in the future?
Florida Power and Light and Next Air Energy is utilizing autonomous drones like the Perceptos and the Teros that we have now. Vegetation management specific, we are visual line of sight. We're hoping to get beyond visual line of sight under our Next Air Energy, it's called FPL Air group, the first quarter of next year. So right now we utilize everyone else's collection that throughout our company that they're using, but from vegetation, it's usually a plane, a helicopter, even a car, right on the ground. And we have pilots as well that use drones.
Feel free, Drew or Mark, feel free to interject if you have any perspectives.
So for aerial production services, we don't currently do any autonomous flights. We are diving into the space of beyond visual line of sight. We do beyond visual line of sight flying in North Dakota on a specific sector or a specific right of way that we have FAA approval to fly those flights on. What's interesting is applying for those waivers and getting the FAA on board with doing those really crosses, they intersect with building a digital twin of the right of way. To get approval through the FAA, you've got to know and mitigate every single possible risk that could come up, whether it's a road crossing, whether it's a private residence, and maybe that private residence walks out. How do you mitigate that risk? So building a digital world to be able to show the FAA, these are the steps that I'm taking to mitigate those risks, really accelerates and improves your chances of getting a BVLOS approval. And as Tim said, there's thousands and thousands of BVLOS approvals that have gone out. There's very few companies that are actually executing beyond visual line of sight flights. And where that fits in with automation is once you can get that BVLOS step done, flying beyond visual line of sight, then you can start working in automated flights based upon what you've learned from BVLOS. But we've all got to take that step first. We've all got to understand the risk and mitigate all those risks before we can take that next step to automate these flights and do it safely.
Yeah, I'll just add on that, Emerson, they cut their teeth, their genesis in the mining industry. So you could imagine if this was a cave, 1,000 meters below grade, there's no GPS. So, their capability is autonomous flight. It'll figure out where it is. You can give it a waypoint and get from point A to point B. In the oil and gas sector, as Bank of America, I think, pointed out on Tuesday, oil and gas, we're very undercapitalized in that digital transformation. So it's a target-rich environment. Where you're seeing growth is in the offshore industry. So flying a UAV, capturing data in the undersides of a platform. I can't see it, but I can program that drone to go down and collect data. It's safer, faster, and cheaper than rope access, building scaffolding, or hanging someone over the side. We're just in the infancy stage of adoption. And there was another speaker yesterday. You don't know you have a problem until someone shows you have a problem, and here's a solution to address that problem. So we're low in adoption oil and gas, but it is a target-rich environment.
Anybody else?
Dave Dollar with Hexagon. How are you dealing with hazardous gas environments, classification, class 1, div 1, class 1, div 2, specifically for the drones?
With the equipment that we're utilizing, especially on the drone, we can stay outside of those classification spaces. We don't have to get that close to them. These laser scanners have a pretty wide field of view, and as long as you can get an angle in to capture underneath the pipe from 15 feet away, then the data is going to be just as good as if you were right beside it. And then flying, we don't have to get right down on the pieces of equipment. These LiDAR systems are quite robust to be able to capture good data from 10 meters high or 15 meters high, and even further than that. I think the Innocent hover maps range is up to 50 meters high or something similar to that. Of course, there's other LiDAR systems that's the typical range where you would fly it at. The versatility with the hover map system for that compressor station is we could fly it lower, still outside of those classification spaces, but we could get different angles that we wouldn't be able to get with other LiDAR systems.
That's a great question. That's really the crux in the oil and gas industry. Any sort of hot work, electrical charge, discharge, powerization that could create that infamous blue spark ignition, that's a no-no. So all work is permitted under a hot work permit. So the atmosphere is assessed. It is ensured that any sort of hot work that could create that spark It is managed under a work permit. So if this was a module, either onshore, offshore with process equipment, think of vertical, horizontal separators, a bunch of pipe, walkways coming in, going out. I have fugitive gas, it's leaking off a tubing, valve stems. It's there, but in low concentration. So the robotics, whether it's spot, whether it's a crawler, whether it's a drone, to do work in there today most likely is in a hot work permit to manage the risk. The payload, the sensor package, that too, if it has the potential to create a spark to be ATEX or Div 1 Class 1 certified, is probably going to be a lot larger, a lot heavier, and enclosed. So we have to work with the delivery mechanism and the payload eventually to be both there in a hazardous environment. Okay, great question.
Anybody else want to take a shot at that one or no? Okay.
So I have the mic.
Question, go ahead.
So first of all, thank you both for those presentations. Outstanding work. I think that's amazing to see those kind of direct examples. My follow-up question is for Carrie. And so when you're flying drones in like the neighborhoods and things like this, how high do you go? And I would imagine at some point residents freak out because there's extra activity. How do you have to communicate that to people?
We notify the customers prior to drones being in the area. Oh, sorry. Can you hear me? We notify the customers prior to the drones being in the area. I'm with the vegetation management department, but we have many other departments. So there's automated calls going out. There's mailers going out. There's a phone number if they have any questions prior to the flights happening that they're able to call, and we're able to work through. Did you ask me how high also we're flying? For vegetation management, specifically for LiDAR, we're about 250 feet above the lines.
Is 400, my understanding, is that the kind of, for the FAA, is that the normal altitude for BVLOS? I think it's around 400, yeah.
400 feet's the ceiling for drones.
That's kind of the FAA ceiling for pretty much most flights. 400, yeah. That's kind of that's for, if you want to go BVLOS, that's my understanding is 400 that's it.
So great presentation. I see some of that stuff and think, okay, I'm living in the future. Or more to the point, you're living in the future. So my question is, from your perspective, where you're already living in my future, what's your future? What are you thinking that's going to be coming along in 3 to 5 years that's blowing your mind? And we've talked a little bit about the autonomous flight. Are there any other things that you're seeing that you're expecting? I'm going to be here in 3 years' time, and you're going to be presenting another one, which is going to be equally amazing.
For my space and vegetation, it's more what I talked about, predictive growth modeling, understanding the change detection from one flight to the next. That's really big for us. So I don't think it's quite 3 years off, maybe half that time before we really have a solid handle on that. And really just equipping our inventory, our partners, our vendors, having them also integrate some of this technology into their workflows and processes as well, right? When they're done, maybe on their trucks, on their person, right? Collecting imagery that way as well.
I'd like to add to that, if I can. So this will make you laugh, a little humor last day. So here's the journey I've been on. My first inspection data management software program was DOS-based. My first cell phone was a Motorola Brick. My first PC was an IBM 386 with a Mathco processor. My cell phone today has more computing power than the Apollo missions. Today a technician in the field, we have wearables, HoloLens, RealWear. If they have a problem in the field, they can speak to a center of excellence anywhere in the globe as long as they have cell phone. So if you need real-time support, I could have that 24/7 with COEs strategically displaced or placed to support your operations. You see the onset of machine learning, data visualization, AI. I'm a big sci-fi person, so Terminator, 2001 Space Odyssey, it's coming. What excites me, I wish I knew what I know now. I wish I could wake up Monday morning at 25, because some of you younger people in the audience, it is going to be a very exciting future of the next 15 years. The pace, what has happened in the last 30 in my career and what's going to happen in the next 5, 10, 15, it's hard to define. So the tools are getting smarter. You're able to leverage the data. I think the biggest challenge for any operator, regardless of sector, what data do you need to make sure that your operations are safe, reliable, and effective? And whatever programs, whether it's reliability, mechanical integrity, do you have the right tools? That pushes the burden on your service providers. And I love the challenge I heard yesterday in the opening, Mark, on the software people, so that they really need to get their act together. There's more collaboration, more open source. So if you want to switch from a Bentley product to GE Digital, that's a seamless process rather than tens of millions of dollars. In my industry, we're undercapitalized, but it's a bright future. As we transition to a more green, we'll call it business model, we need technology. And I don't know what the next 5 or 10 years, but I know there's very smart people working on solutions. And if I was a young person joining the oil and gas, I'd be rather excited, because the power of sitting a 3D model in your office in Houston and looking at a plant in the desert of Oman and talking to a technician maybe in Aberdeen offshore in the North Sea with a similar problem, didn't have that 10 years ago. So the advancement is going to be huge. Whereas, hover map and technologies like that, you're a fast, a leader, leading edge, fast followers, and then adoption. So exciting times.
From my perspective in dealing with the oil and gas industry and where do drones go? Where do they have a place? Where does all this data lead us? It's interesting because the data that I'm collecting now for a specific problem today, I'm going to utilize 5 years from now. I'm building off of what we're learning today. We're capturing sites, we're digitizing them today. We're doing that now. How does that help me 5 years from now? I'm going to build autonomous regional inspection services from that. So beyond visual line of sight, it's going to come. It's hard to get, but there's got to be people out there like our company that is pushing hard on the FAA to allow us to do these things, to push the limits of BVLOS, to be able to understand what we can do. So past BVLOS, that's where the regional operations come from. One pilot inspecting 150 well pads out in North Dakota, all autonomously. He's monitoring one station with multiple drones flying, collecting methane data on each of those well pads, feeding that directly to our customers so that they can make the decision to which leak are they going to fix, reducing greenhouse gas emissions across the board. But we have to start where we are now, and we have to not only solve the problems for today, we've got to look forward. We've got to utilize the data that we have to be able to build what we're going to do in 5 years.
Okay, my name is Becky Morgan. I work with manufacturing companies, and so this may well be a selfish question. I apologize, indulge me. Drew, you talked about doing the inside of the compressor building. Can either of you, and I don't really expect you to be able to answer this question, can either of you speak to real life examples of how manufacturing companies are using drones inside their buildings to help understand equipment conditions or anything else?
So along with the point cloud data that you gather from the interior of the compressor station, laying out exactly where the piping is coming in and going out, understanding how big your compressors are. What if we've got to replace a compressor? How are we going to get it in? What's the dimensions of the building? And then, of course, layering on visual aspects of it. Maybe it's I don't know if you've seen the 3D inside a house, viewing things that you can go in, doing the same things in there so that you've got a visual. You can colorize those point clouds. You can model it. You can see corrosion issues. You can see where your valves are at. You can see all of the information in one place and one visual place on whatever software is out there. You take your pick, but they all have those capabilities to tag certain information that's key to you and is important to your company. and tailor make all of those, the interior of the compressor station or manufacturing site just for you. So
I'll build on that. The capability of remote and autonomous inspection is still in the infancy stage. So SPOT, the robotic solution, 700 of them deployed worldwide. In my industry, oil and gas, most are still walking around using a camera to look at an analog gauge. So way underutilized in Mark's opinion. So the dawn of the era of sensor fusion. So what kind of sensors do we need in the plant so we can collect that data and take the human out of it? And that's really in the oil and gas, we're trying to do reduce risk, reduce that head count, especially in an offshore environment, because most people in this audience don't realize your critical path or your constraint is a bed. Without a bed, I don't do work. And if all the beds are full, I can't get work done. So the robotic solutions out there, whether they're crawlers, whether it's spots, whether it's a drone, the future is bright in the sensor payload, making sure we're collecting the right data, and then having the analytics on there for the insights. Again, going back into your manufacturing plant, is it safe? Is it reliable? Do I have the uptime? Are you hitting your metrics? And so we're, from an RAI perspective, there's a lot of runway left. I think we're just beginning, because the sensor fusion and data fusion, we're not there yet. We're just not there yet.
Hello, my name is Fabio. My question is for Gary. I was wondering if you can describe a little bit the workflow from the moment that the drone flight is done and the LiDAR information is captured. If you can comment what happens to that drone, who takes the information off the drone, where does that get loaded to, who adds the GPS coordinates, and then finally, if FPL itself does the model training, or if you use a third-party vendor to do that for you.
Sure. We have different collection methods, but essentially the pilot will collect the data and produce a raw LAS file, which then we feed into visual intelligence, who will then classify the point clouds, design the work, if you will, understand the encroachment. That is then fed into our work management system and then sent out to the crew for execution. So essentially the pilots will collect the data and upload the data to an Amazon S3 repository. We do have a person at that point reviewing the specs of the data to make sure that it meets certain specifications, that it can be used in a proper way. There's data that can be used in this way to go into visual intelligence. It's inside the platform itself, right?
Hi, I'm Andrew Dark. I work in fishing, so listening a bit on the offshore side. One of the challenges we face is extending the reach of the boats in terms of the sonars and listening to what Tim mentioned about the 30 minutes. What's your views from the three of you in terms of what's the current flight times you can achieve? And what's your views in terms of how far do you think it could potentially go? Because for us, we need a maximum reach. We need much more time, flight time, to be able to get a much greater scope of what we're seeing.
And this is from a drone perspective. What kind of flight times are you trying to get to?
Yes, the further you can go out, the existing sonars can maybe reach out, I don't know, about 1 kilometer. What you want is that with drones, you can go much further out, 5 kilometers, 10 kilometers. And that means time. And you also want to cover a much greater area. Yeah. And you don't want the drone to run out of battery and then fall in the sea.
So I think we're all kind of in the same position with battery life when it comes to drones. And even in the car industries, you look at Tesla, everybody's rushing to get who can get the most range out of the piece of equipment that they're using. For your situation, especially if it's offshore and not within like the FAA's control, then you're talking more of maybe a hybrid type drone where you're not using all battery. Maybe you're using hydrogen and running generators to run the props. And those types of solutions, you can get 2.5, 3 hours. And I've seen some of them that are saying they can get 5 hours of flight time. I haven't tested any of those, but that would be, if I'm looking to solve that problem, I would look into the hybrid drones situation. So,
yeah, I'm not a drone expert, but there are commercial solutions out there that have tremendous payloads. They're like a miniature version of a helicopter. So they're out there today. The inventory is growing and their capability is growing.
Yeah, you can do, I mean, some of the tethered ones I've heard, they can go up for 10 hours. I mean, it's just a question of the range. And then if you talk about the hybrid, some will gas and battery operated. So there's some of the ones that are fixed wing. They can, they're pretty expensive, but they can go, yeah, they can do, long distances, multiple hours, tens of, 50 mile, 100 miles maybe, or something like that. But most of the ones, I mean, the rotor ones, you're going to get plus or minus. I think DJI just came out with a new model, and they were saying maybe, 50 minutes. And I was asking someone, well, how much payload is that? And I don't think it had a lot of payload, because obviously, as you add more payload, obviously your battery power is going to be reduced. So it's always battery technology, like anything. It's smartphones, anything. It's cars, electric vehicles. I mean, it's a limiting factor. So I think there are options out there, but it's also a trade-off of how much money you have, and because some of these guys, I saw a video. Shell was using one of these in situ drones, and they had a guy at the remote control center. I was talking about the remote controls, and then there's a company that's Hala Sky, HHLA Sky. Their parent company is HHLA in Hamburg, and they do all the port operations and things like that. And they had a unique situation for their operations. They basically had to build their own drone solution. And these guys are ex-Siemens guys, so we were talking. I said, like, knowing you guys are ex-Siemens, I said, you over-engineer the hell out of it. But they have the most, in my mind, the most comprehensive end-to-end solution of drones I've seen. They can manage over 100 drones remotely with one guy in a remote control center. And it's pretty fast. And they told me they're coming up with a drone-in-the-box solution. So they've been focused primarily in that, because that's their big experience. 180 customers, but they're mostly port and container guys. But they're looking at, could be applied to wind turbines, oil and gas. I would recommend checking out that solution, because they pretty much built a nice drone solution. So it's a bigger size, because I think they have ranges of like 3 kilograms, 10 kilograms. So there's different payloads they can carry, and it's a pretty impressive end-to-end solution. It's okay. We have another question. I'm sorry.
Hi, I'm Mike Davis. I'm with Novatech Automation. For the whole panel, but Carrie got me thinking about that. You said FPL has other uses besides vegetation management for the data you collect. And I was wondering if you have reached out or been contacted by anyone that wants secondary or tertiary use of this data, because your LiDAR data is unique. I don't know if there's someone at UF in Gainesville that is interested in how vegetation is changing over time, or invasive species of plants, or it can go on and on to anyone who wanted a 3D model of some part of Florida. You've got it already. I was wondering if any of you have thought of commercializing your data or been approached in that way.
It's a whole new thing. It's just in my mind, I'm thinking it could be a whole different business model. You'd be selling data in the future, not just
Right. I don't want to say no. I'm not privy to that, but I know that we understand that we have data that can be used far beyond what we're using it for. So those conversations will be had in the future.
Yeah, you've touched on a really good point. The technology, Emerson's technology, its speed of data acquisition compared to traditional tripod terrestrial systems. So think of emergency response, flooding of an area, a bridge collapsing, an explosion, an industrial accident. So you could, if you had the before, you could quickly acquire the after. So from condition monitoring, emergency response, there are, I won't say endless opportunities, but we're just beginning to tease those out. Really, there's a lot of educating the operators, the plant. Here's how we can help you. They may not know they have a problem. We may have a solution that could solve many problems from a data ingestion and decision-making process.
And to touch on that, just to touch on that a little more, we're experiencing the same, inhibitors that we talked about, battery life, right? Visual line of sight only, the payload, trying to jump, the sheer number of miles. But thinking of it in the terms of where you are, and letting our pilots know this data is used beyond just what you're looking at right here, right? So keep that in mind, and you have to factor that into the equation as well when you were looking at the time.
And there are other entities. Take Texas, for example. They go out and do LiDAR scanning of their entire state. I think the some division within the state of Texas goes out and captures all of this. But you also got to understand what's your use case. I mean, if you're utilizing that Texas data, we can show you some comparisons. They're flying it from a much higher height. They're getting, maybe a point per foot is the density of their point cloud. Whereas if you're flying it with a drone, you can get upwards of over 50 points inside that foot. So if you're looking for 1 foot contours, maybe that data is right. Maybe you can utilize it for another purpose that you're looking for, but you got to understand not all point clouds are the same. They're used for a lot of different things, and I believe Carrie's Florida Power and Lights, they utilize a multitude of different LiDAR sensors to capture, maybe it's vegetation, maybe they need it on a drone, or maybe it's for transmission, and they can utilize a helicopter with less dense point clouds to get the data that they're needing. So,
Any more questions? Well, we got about a few minutes left, and if there's no more questions from the audience, I'll just ask each of the panelists up here to sort of just give a minute or two, probably a minute, I guess, with the time. Just sort of any last minute thoughts or key takeaways that you want the folks in the audience to kind of, really take home. Could be just a synopsis or whatever.
My key takeaway is that you have to try. You have to get into this space to see, right? You're never going to know unless you do that. And some of the initiatives and the innovation that we're doing, it's really exciting to see, the Percepto, Spot, all of that you showed, we're incorporating, and we didn't know necessarily all the use cases we would have for these equipment, but we put one in our mind. So the takeaway is jump in there and see, right? You're not going to know unless you take that first step. And I encourage everyone to do that and be innovative, right? Be disruptive. And that's how we're going to change the industry.
Amen.
I agree. From a service provider standpoint, we're always trying to find new business and things like that, but that's not our major push. We're not going to continue to grow as a company unless we educate, the rest of the people out there that are looking to do this. So we'll partner with people. We'll help guide them. Okay, so you're jumping into this brand new. Let us help you dodge some of the hurdles that we've already hit up against and spent countless hours trying to figure out a way around. And that's how we push this industry forward. It's not charging you for, a phone call to say, hey, how did you accomplish this? How did you get around this barrier? But, communicating across the industry and saying, this is how you get this done. And if you ever need any help, give us a call. And we're always here to push this forward because it's in the best interest of our company too.
I get to close. As an ex-operator, work with a cross-functional team. Don't try to solve a problem in a silo. Bring in maintenance, reliability, HSE, whatever the construct of your organization. Have representation from multiple disciplines. 2, be bold. You don't know what you don't know. And there are others out there that may be working on a solution you're just not aware of. So you've got to have access to a pipeline of information or technology, whether that's through forums or workshops or strategic partnerships. In my career, I was always able to deliver a solution to solve a problem when I worked with a strategic partner rather than to design it in-house. I always had a better product, faster, cheaper, minimal viable product. I could go out there, I could test it, influence it rather than self-development. So I would just encourage you, keep an open mind. If you're in the oil and gas sector, at times we're caveman, we're behind the manufacturing curve. The data here supports that. A bright future, remote and autonomous inspection, it's a game changer. We're going to repurpose our workforce. It'll be safer, more reliable because hydrocarbons, we need them. My unborn grandchildren will have hydrocarbons in their future. They may be less, but they'll still be there. So be bold.
Amen. Thank you very much.